Hello guys, welcome back to my channel, Mason African Motives, as we shall be working on Mechanotechnics N4. So still working on the continuation on precision measurement, as we saw that in our last class we managed to work on the question paper which was written in February 2020, which was the first part where we managed to calculate the diameter for the given roller that we had. And this time we are given another question now, which was on 2.2, and to make it 15 marks. As you can see, guys, that was a total of 15 marks in all. So this time we just need 7 marks there. So this is the question that we have. So if you're new, guys, you can consider subscribing to this channel so that you won't miss any of the classes that we shall be having from Mason African Motives. So looking at the question there, actually we are given in fig 2 below, which is this fig 2, shows an external dovetail machined to an angle of 40 degrees. Okay, so that means this one is actually machined to an angle of 40, two precision rollers. So these are the two precision rollers that we are given. So that actually means we've got the same thing also on this side. That will be our 40 degrees there, and each with a diameter of 15 millimeters. That is the diameter here of 15 millimeters from this point to this point. Okay, which means the same thing from this point to this point, from this point to this point. That's 15 millimeters. I used it to test the angles for correctness. The dimensions are given in millimeters, so all the dimensions that we are given are in millimeters. And the question was, use the given dimensions to calculate the distance x. So we want to calculate this distance x between the inside faces of the rollers if the two angles were correctly measured. All right, so if these two angles are correctly measured, what is going to be the distance x? All right, we have actually not a lot, but something else. So you're supposed to just make a sketch, but I'm just going to use this one, guys, as my sketch. Okay, because here we do not have like much to put into consideration here. I want you to see that, like previously we saw that when we calculated the diameter, it was like in the horizontal, which is the same thing as our x. As we can see, from this point to this point, it's also in the horizontal. Or let's just make a sketch, but a sketch, guys, is going to cost us much time, because these diagrams, as for me to redraw them and do this, actually is a problem. But we had got something like this and like this here. This is our x. All right, I can see that this is going to be too small, but I'm just going to work much better here, like this. This is what we have here. All right, if you are to cross-check here from this point here, from this point where the circle is ending here, at that point here, I want you to see something at that point. So I'm just going to separate these diagrams so that you can see this point here. This is the diameter from this point to this point. That's a diameter, because this is radius and this is also radius again, which means we have got, remember, our radius, guys, is diameter over 2. That's our radius, which is diameter over 2. So that means it's simply 15 millimeters for the diameter divided by 2, which is 7.5 millimeters. So let's just name our points and see what is going to happen, because we have a point here, which is the same concept as this way here. We have got the same thing, and here that's our final point. So I'm going to name these special points as from A. I'm going to have my A here. Let's put our B, our C. Let's just put our C here, because this is one thing. So let's just put our C here, and from C to this point, that is our X. So let's just put our D. This is the whole diameter, so let's skip this point and just put our E here and our F at the end. All right, like that. So this is what is going to happen, guys. All right, this 110 millimeters, it consists of all these points, and also it consists of X. So that means from A to F, let's just form an equation here. that is going to assist us in finding this x, because as you can see, x is part of this 110. So which means a to f, which is 110, is equal to, let's combine our AF, that's AB plus BC, AB plus BC plus from C to D, which is X. So we can just write it CD, but this is our X, all right? Then DE and EF. So plus DE plus EF like this. Then there are some things which we are given here. We said from B to C, this is radius times 2, which is the diameter, because this is radius. So that is 2r. So in actual sense, guys, we can take this into consideration, or we can just find this value here because we are given something like this here. All right, so that we can just find this length here from this point to this point again, so that we can remove this part and separate it here, and also separate it here, because as you can see, if we consider this AB, we can't like determine it at once. So I want us to separate this portion here and use this triangle here. Let's just say this is O, this is our point O, and let's just put this as a Y like this, okay, at this point here, so that we can find this distance from this point to this point. Okay, so this is what it's going to look like. So we shall adjust that equation later on. This is what it looks like, guys, like this. I just want to take the part that I want us to work on. This is what is happening, like this. I want us to work with this triangle here that is going to be formed here, this one. All right, so there's a triangle that is going to be formed like this. And remember, this was 40 degrees here. All right, so this angle here is the same as 40 degrees, but is going to be bisected, because remember I talked about the concept of tangents, that whenever there's a tangent like this, when you draw from the center to the tangent, it bisects these two angles. So this angle is going to be divided into two equal parts. But we know that this angle is the same from the concept that these are parallel. So as you can see, we are forming a Z like this. So if this is 40, this is also 40 degrees. So it's going to be 40 degrees divided by 2, which is 20 degrees. So this is going to be 20 degrees, 20 degrees here. Okay, and we say this is our A, O, and Y there. So this is O, Y, and A like this. All right. Remember, from this point O to Y is also the radius. So this is the radius, and as we can see, we said radius is 7.5 millimeters here. We talked about the radius because we said we have 15 millimeters. So 15 divided by 2, which is 7.5 millimeters. All right. So which means here we've got the radius, which is 7.5 millimeters. Let's just write 7.5. So we can calculate this length. Why are we focusing with this length? Because it's in the horizontal, where our x is also in the horizontal. All right. So what can I use? Because this is a right angle triangle. Remember, radius and the tangent, they meet at 90. So we've got opposite and adjacent like this. So which means I can apply the ratio for tan, because if opposite and adjacent here, is that so? That's tan from your soccer tour. Tan is opposite of adjacent. So tan 20 degrees, which is this angle, tan of 20 degrees is equal to the opposite here, which is 7.5 over the adjacent. This is our adjacent, which is AY. All right, let's just say over 1. Then we can find AY, so we can cross multiply. AY tan 20 degrees is equal to 7.5. Then we can divide by tan 20 degrees there by tan 20 degrees. All right, so this can cancel. My AY is going to be this divided by this, which means we are going to obtain something like 20,66. That's 06 there, 08, something like that. All right, so to 3 decimal places, that's going to give us 20,606. Okay, because this zero cannot change, but this is in millimeters. So that's our AY, this one, which is 20,606 millimeters. Okay, remember our AY, guys, is covering this AB here, this AY here, this A to Y. Remember I said this is our Y here, is covering AB. So AB is not included, it's already covered here in AY. So we are just going to remain with this radius here. This is what we are going to remain with this radius here. All right, so we are just going to remain with that radius. So that means okay, let's just put this aside, this one. There's something also that you want to note. From this point here, if we do the same, because these two figures are similar figures, but they are not similar, they are congruent. Congruent meaning to say they possess same properties. So here you're going to see the same thing also here. You're going to form the same triangle just like this one. So which means we have got this distance, let's just say this is Z here, which is going to cover from Z to F this one, which is the same as this one of A to Y, this one. Remember we said this one is no longer there. From A to Y, this one that we calculated is the same as from Z to F. So this one, let's not include it, from Z to F. Since these are congruent figures, these distances are the same. So we are simply saying AY, this one that we have, is equal to ZF, which is equal to the same value as this one of 20,606. So these two are equal. So we are not going to calculate this. And this is the radius also, so which means this represents the radius also, just like this part here, which is represent the radius like this. And we said radius is equal to 7,5. So that means, guys, we can come back and conclude this information now to find this distance x, because everything is now there. So that means this 110, this one, is equal to, we remember A to Y, the one that we calculated, this one, from A to Y, this one, we obtained this value here. From A to Y, that is the value that we obtained. Actually, I wrote it here, okay, 20,606 plus, okay, let's move on. This value here, the radius here, because it's A to Y, and from Y to C, this one from Y to C, which is R, but R is the radius, which is 7,5. So plus 7,5 like this, plus from C to D, that is our X, which is this one. So it's plus X, plus what else? From D to Z. Remember we said this is our Z. From D to Z, this is R, which is the radius, and radius is 7,5. So it's plus 7,5, okay? Plus Z to F, so that we can conclude this 110 meters. So it's Z to F, and we said Z to F and A to Y are the same, which is this one. So it's going to be plus 20,606 like this. All right. So as we can see, guys, we have formed an equation that we can simply use to calculate this value of x. So how are we going to calculate now this value of x? We can just transpose, guys, take all these values to the other side of the equation. That's going to be 110 minus 20,606 minus 7,5 minus 7,5 minus 20,606, which is equal to x. So therefore x is going to be, you combine everything here, which is going to give us 53,788 millimeters. So this is going to be our X. So guys, Mechanotechnics uses concepts, workings and calculations of previous or which were used in the past. So that is all about precision. The stages or the steps that you follow should be linked with mathematical proof, which means you must use your mathematical skills to answer these questions. That is all about mechanotechnics. You must use all your mathematical skills because it's all about joining and combining those mathematical skills to calculate whatever that you're asked to calculate. So anyways guys, that's what we had from this platform, working from Mason African Motives on Mechanotechnics. Till we meet again.